Today we're going to do the factor theorem right here. To do the factor theorem, all that means is we're going to use the remainder theorem we just learned, and we're going to divide this factor into this. If it divides evenly and the remainder is 0, then we have a factor. So what we're going to do is we're going to set up our synthetic division, and I'm going to use 1, -7, 7, and 15, because that's all my variables. And then here's the key. This factor needs to be changed where we change to the opposite sign. So -5 becomes a +5. Now if we get a remainder of 0, then this is a factor. So I'm going to do my synthetic. So 5 times 1 is 5. So 5 times 1 gives me 5. Add, I get -2. 5 times -2 gives me -10. I add, I get -3. And then when I multiply, I get -15, and when I add, I get 0. So basically what this says is if I have a remainder of 0, then this is a factor, and so is this. So I put my letters in. Remember, we always go one less than what we started with, so this would be x squared minus 2x minus 3. And I already quoted that x minus 5 is one factor. Now, the issue is this right here can also be factored. And when we factor that, I think it becomes x minus 3, x plus 1, because -3 times +1 gives you a -3, and when we add, we get a -2, so this is what it adds to, this is what it multiplies to. And so we're taking what we've just done before and did factoring. We're now using what we're doing now, the remainder theorem, to get our other factor, and we've now factored this up here. Okay, once again we're going to factor this, and this time I'm going to use the substitution. So I'm going to substitute 2 into this polynomial. So 2 cubed, 2 squared, 2 times 4 plus 12. If this equals 0, then this is a factor. So let's see if it equals 0. So let's go through. This is 8. 4 times -7 is -28. This is 8 plus 12. And when we do the math, we get 0. So that means x minus 2 is a factor. The problem with the substitution method is it doesn't give us our other polynomials. So now I'm going to go back and I'm going to do the synthetic division. And the reason why I'm doing the synthetic division is because the answer, when it's a remainder of 0, is our other factor. So I put my numbers in here, -1, -7, 4, and 12. I drop down my first number. So I multiply, I get 2. I add, I get -5. I multiply, I get -10. I add, I get -6. I multiply, I get -12. And when I add, I get a remainder of 0. So we've already established through the substitution method that this is a factor. But now our other factor is this polynomial, and x minus 2 is one factor. So from here I can factor this as x, looks like we'd have a -6 and x plus 1, because -6 times 1 is a -6. When I add those, I get a -5. So here is my answer, all the factors of this polynomial.